Please subscribe, and you can download this code from description below. Title: Design Heuristics for Python Classes Interacting with scipy.integrate.odeint. When working with scientific simulations and mathematical modeling in Python, the scipy.integrate.odeint function is a powerful tool for solving ordinary differential equations, ODEs. To enhance code organization and maintainability, it is beneficial to design Python classes that encapsulate the integration process and related functionalities. In this tutorial, we will discuss design heuristics for creating such classes, providing a clear and modular structure for code that interacts with scipy.integrate.odeint. A well-designed class should allow users to specify essential parameters during initialization. For an ODE solver class, this includes the ODE system function, initial conditions, and any other parameters required for integration. Isolate the integration logic within its own method. This promotes modularity and allows users to focus on the integration aspect when using the class. Add methods to the class that facilitate the analysis of the ODE solution. This could include plotting, calculating specific metrics, or extracting relevant information. Allow users to configure integration parameters and methods by providing optional arguments or methods in the class. By following these design heuristics, you can create Python classes that interact with scipy.integrate.odeint in a clear and organized manner. This promotes code reuse, readability, and ease of maintenance, making it easier for both developers and researchers to work with ODE systems in a structured way. ChatGPT. When working with scientific computing and numerical simulations in Python, the scipy.integrate.odeint function is a powerful tool for solving ordinary differential equations, ODEs. To enhance code organization and reusability, designing well-structured Python classes can be beneficial. In this tutorial, we'll explore design heuristics for creating Python classes that interact with scipy.integrate.odeint and provide a code example to illustrate the concepts. Start by designing a class that encapsulates the ODE problem. In the constructor, initialize the essential parameters required for solving the ODE, such as the ODE function, initial conditions, and time points. Include a method to set or define the ODE function within the class. This method allows users to specify the ODE function dynamically. Implement a method to solve the ODE using scipy.integrate.odeint. This method should take care of calling odeint with the provided parameters and return the solution. Include additional methods for flexibility, such as setting new initial conditions, changing time points, or retrieving specific components of the solution. Now, let's put these heuristics into practice with a simple example. Consider a first-order linear ODE. In this example, linear ODE is a class representing the ODE, and ODE solver is a class responsible for solving ODEs using scipy.integrate.odeint. The user can easily swap out the ODE function, set new initial conditions, and retrieve specific components of the solution. By following these design heuristics, you can create reusable and flexible Python classes for solving ODEs with scipy.integrate.odeint. ChatGPT. Certainly. Designing Python classes that interact with scipy.integrate.odeint requires careful consideration of various aspects to ensure a robust and efficient implementation. In this tutorial, I'll guide you through some design heuristics and provide a code example for better understanding. Start by organizing your class structure. Consider creating a class that encapsulates the ODE system, parameters, and integration settings. This helps in maintaining a clear and modular design. Design an __init___ method to initialize the class. Include parameters for the ODE system, initial conditions, integration time span, and any other relevant parameters. Create a method to define the ODE system. This method should return the derivatives of the state variables. This function will be passed to ODEint during integration. Implement a method for numerical integration using scipy.integrate.odeint. Provide options for customizing the integration method, such as specifying the integration method, method parameter, and tolerances. Include methods to access and manipulate the results of the integration. This can involve extracting time and state information, plotting, or saving results. Document your class thoroughly. Include docstrings for class, methods, and parameters. Explain the purpose of the class, input parameters, and expected outputs. Implement error handling to gracefully manage potential issues during integration. This may include handling integration failures or invalid input parameters. This example demonstrates a simple ODE integration using the ODE integrator class. You can customize the ODE function, initial conditions, time span, and integration parameters based on your specific system. ChatGPT